Good day, fellows. Today we are going to do the new concept of waves. See, what do we mean by the term wave? It's a change of disturbance or the oscillation of disturbance. But let me take this one, the oscillation of disturbance. I don't have a space, disturbance. See, that's a simple definition of what? Of a wave. Waves can be divided into two. We have mechanical waves, which requires a medium. Mechanical waves, such they require what? A medium. We also have non-magnetic. So the non-mechanical waves. Non-mechanical waves, they don't require a medium. Let me say not require a medium. Do you still remember what are those for mechanical? We have two. Firstly, we have a transversal wave. We also have a longitudinal wave. Then as for non-mechanical waves, we have light waves. See, but for the sake of this video today, I'm going to dwell much on the transversal waves. What are those? Let me just give you a diagram first. Let's see if I have a diagram like this. Here we have a transversal wave which moves in x direction, but its oscillation, they always perpendicular to the direction or the motion of that wave. You see, we have the direction here, then this one, these arrows, they represent what? Oscillation. Then its oscillation, they are perpendicular to the motion of what? Of a wave. Then we see such are transversal waves. Waves of which oscillations are at 90 degrees to the motion or direction of a wave. You see? Then okay, now then at this point, I'm going to try by all means to explain or to label this given diagram. We have these points here. You see these points, the maximum points. We call those what? Crest. Yeah, we call those crest. Are your maximum points. Of a wave. Let me erase here and here. We also have what? The minimum. We call those what? Trough. Your minimum point of wave. Then we also have these dotted lines. We call those equilibrium. See? Then, what do we call this line from equilibrium to the maximum point? What do we call that line? Do you still remember? We call it an amplitude. This is an amplitude. Let me write A for amplitude. We call it an amplitude. I don't have much space there. A maxi, sorry, it's a distance from equilibrium to maximum, or say even a minimum point of a wave. See, we also have another amplitude here. We have another one. You see, those are our amplitude. Now let us try to identify a wavelength. Let me draw this wave again. Then for us to be able to find the wavelength of this given diagram, we must try by all means to identify the sine function or the cosine function. Do you still remember those graphs from trigonometry? Check, it's so simple. One complete cycle is going to form sort of a sine graph. You see, sort of an S shape like this. From here to here, we are going to have the first amplitude. You see, the S shape, like sort of S shape like this. You see, then we also have another one. Starting from here, we complete our cycle. We have another one. You see, at the end of the day, we have how many amplitude? Two of them. Then there is another way of identifying what your 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 amplitude. You can use what? Sorry, your wavelength. You can use your crest. You see, from one crest into another, we have full cosine graph. We also have from this one till this one. You see, another cosine graph. This is our wavelength. You see, but at the end of the day, we are going to have 1, 2 full wavelength. Then this was just a little bit of a summary for the transversal waves. You see, it's so simple. I thank you.